deaerators, which are crucial. This decreases performance and can even cause a breakdown of the entire boiler turbine system. Thus, it is regulatory to maintain the TOC levels. The TOC limit for boiler water is 100 to 200 parts per billion. Hence, TOC monitoring is important for the protection of the boiler, which further leads to optimization of water and steam cycles. To reduce the TOC levels, supercritical thermal power plants adopt organic scavengers and polishers. The TOC level is monitored at both inlet and outlet of the polisher, such that TOC levels are maintained within limits. Cooling water cycle. The cooling tower's operation is water intensive. Typically, 90% of the water required in power plants is dedicated for cooling purposes. River water or clarified water are fed into the cooling tower bay. This cool water flows to the condenser and cools the steam exiting from turbines through heat exchange process. The cool water gets heated in this process and is returned to the cooling tower to cool down further through air drafts and is collected back into the bay for recycling. It goes through several cycles before it is sent for treatment. The presence of TOC in cooling tower water causes biological fouling. Higher levels of TOC rapidly accelerate the biofilm formation. This further leads to formation of a biofilm in the cooling tower inlet bay area. Cooling tower pipes, walls of the cooling tower, inside spray nozzles, inside condenser pipes, etc. The biofilm formation inside condenser pipes will drastically reduce the heat exchange process, leading to the inefficiency of the condenser. The level of TOC builds up with each cooling cycle. The general discard limit of cooling water using TOC is 70 ppm. After this limit, TOC in the water will damage the cooling tower and condenser quickly. Hence, timely monitoring and blowdown is advised for cost efficiency. Wastewaters are collected from various sources in the industry like floor drain, office building drain, coal yard watering drain, coal handling equipment drain, UF, RO, DM, polisher regeneration drain, boiler chemical cleaning drain, heavy fuel oil HFO and light diesel oil LDO tanks area drain, cooling tower drain, etc. All these effluent waters are collected in a tank and treated in effluent treatment plant for reuse in the industry. ETP has several treatment stages. Wastewater treatment. In the primary stage, wastewater first passes through bar screens to remove large solid objects and then through a grit chamber to eliminate grit like ash, clinkers, etc. Finally, it enters the primary clarifier to remove sediments.